Welcome to part 3 of our front-end track, the DOM or Document Object Model. This is where your JavaScript finally meets the page the user actually sees. Here's the core problem. Your JavaScript runs in memory, holding variables and logic, while the rendered page lives separately as pixels on the screen. When your code sets some text or styles an element, there's no automatic link between those two worlds. JavaScript has no direct handle on what's drawn, so something has to connect the code to the page. That connection starts with the DOM. When the browser loads your HTML, it doesn't just display the text. It parses every tag into a structured tree of objects called nodes. The document sits at the root, branching into the HTML element, then head and body, and down to each heading, division, and button. This live tree of objects is the DOM, a model of your page that code can navigate and manipulate. So how does it actually work, end to end? First, your script loads and JavaScript begins running. Second, the browser parses the HTML and builds the DOM tree in memory. Third, your code reaches into that tree, selects a specific node, and reads or changes it, its text, its attributes, its styling. And fourth, the moment a node changes, the browser updates the screen to match, repainting the affected part. That cycle is the heartbeat of every interactive page. Script runs, tree is built, a node changes, and the display updates to reflect it. What lets JavaScript reach into that tree is the DOM API, the bridge between your code and the live page. On one side sits JavaScript, holding your logic and event handling. On the other sits the page, with its real rendered elements. The DOM API spans the two, exposing methods to read, create, update, remove, and listen. It works in both directions, so a single interface lets your code both inspect the page and reshape it. Now add the user. Events like a click, a hover, a scroll, a key press, or a form submit all fire through this same system. When an event fires, the browser runs your handler updates the DOM, and then the rendering pipeline kicks in. The browser reflows to recalculate layout, then repaints to redraw the pixels. Understanding that reflow and repaint cost is what separates smooth interfaces from janky ones, since touching the DOM too often forces the browser to redo this work repeatedly. Because reflow and repaint are expensive, frameworks like React add a virtual DOM. React keeps a lightweight copy of the tree in memory. When state changes, it builds a new copy and diffs it against the previous one to find exactly what's different. Instead of rebuilding the whole page, it patches only the nodes that actually changed. Copy, diff, then patch. That's how React keeps real DOM updates minimal and your interface fast. So here's the takeaway. The DOM is the live tree of nodes that JavaScript reads and reshapes. The browser passes HTML into that tree. The DOM API is the bridge your code uses to touch it. Events drive changes, and every change triggers reflow and repaint, which is exactly why the virtual DOM exists. Master these ideas, and you understand how every interactive web page truly comes alive.